Algebra, Mr. Lawrence here with your flip lesson for the weekend. It'll be a quick factoring review. Remember, we've learned many different types of factoring. We've learned the first one, GCF. By the way, today's date is March 2nd, and this is Honors Algebra. I forgot to say that. Oh my goodness. All right, GCF. When do you try to use the GCF? When do you use the GCF? You always use it. Always use first. It won't always work, but you always try to use it first. All right? GCF. So if you had a problem, I don't care how many terms it has, but let's say 9x squared minus 81. Now some of you might go, hey, that's the difference of perfect squares. It is, but you need to GCF it first. Yeah, let's GCF it. So let's pull a 9 out. And then we're left with an x squared minus 9. And then you see this part here is still the difference of perfect squares, and it will factor more completely as 9 times x plus 3, 9 times the quantity of x minus 3. And yes, Andrew, I know I missed the word quantity in the first one. Please don't tell me on Monday about it. Thank you. All right, so GCF is the first one you always try. Sometimes GCF will be the only type of factoring that works. Sometimes GCF won't work. Sometimes you'll GCF, but then you'll have more to factor on the next step. All right, now I just covered a second type, which is probably my favorite, probably because it's so easy to pick out. That's the difference of perfect squares, right? So the x squared up here is a perfect square, and then 9 is a perfect square, and there's subtraction. So if I have something like this, where I have 16x squared minus, I'm doing this one especially for Quinn because he mentioned he didn't know how to do it when there's more than one variable. It's really simple. The square root, this is a perfect square, this 16x squared, right? Its square root is 4x. 9w squared is a perfect square, its square root is 3w. Difference of perfect squares always factors just like this. And I'm done. Now, I didn't check for the GCF, but I knew instinctively that there wasn't a GCF there other than one because I made the problem up. So technically I did check. Always check for the GCF. By the way, why don't you try to factor this one for me? 25x squared plus 49y squared. Go ahead and pause the video. Factor that one using the difference of perfect squares. And when you're ready to see the answer, unpause it. Well, if you're ready to see the answer, here it is. If you tried to factor it, you were fooled. Mr. Lawrence fooled you. I'm such a tricky guy. It's prime. It's not the difference of perfect squares. First of all, let's back up. No GCF. 25 and 49 do not have a GCF other than 1. Factoring out a 1 doesn't do anything, so I don't waste my time doing it. All right, I've only said that about 10 billion minus 3 times. Okay, now 25x squared is a perfect square. 49x squared is a perfect square. But there's no subtraction. There is no subtraction. All right, it's all addition. We do not have a pattern called the sum of perfect squares. So that one is prime. Okay, so we've talked about GCF and we've talked about the difference of perfect squares. We also have to talk about the trinomial method and perfect square trinomial, and then of course grouping. Hold on one second. Okay, for this one I'm actually going to pull a problem from your homework. And I think I'm going to look at number 24. All right, so this is number 24 off your homework. So that's one less problem you have to do. It's 5x squared minus 19x plus 14. Okay, now, this is a trinomial. Is it the perfect square trinomial? No. 5's not a perfect square. 14's not a perfect square. There's no GCF other than 1. So this is definitely not a perfect square trinomial. It's not a perfect square trinomial in disguise. All right, so I'm going to list the factors of 1 and 5, and I'm going to list factors of 1 and 14. Okay. I know the 14 is positive, so I know after I do my multiplying, I'm going to multiply factors together, I'm going to have to add. My goal is going to be to get 19. All right. Well, let me see here. How could I get 19 out of this? If I did 5 times 1, I would get 5. And if I did 1 times 14, I would get 14. Now, I know I need to add, and that does make 19. The only problem is I don't need 19. I need negative 19. Oh, I'll just make them both negative. Remember, minus in the front, plus in the back. This guy's lining up like the Wendy's double stack. All right, so here's how we do it. Two quantities. These are my x coefficients. I have an x and a 5x. I multiplied 5 by 1. So I have to multiply the 5x by 1. I want it to be a negative 5. It'll be a minus. Then I multiplied the 1 by 14. I'm going to multiply the 1x by 14. I need a negative. Boom. Wendy's double stack, 2 negatives. There you go. Factoring by the trinomial method. All right, let's see if I can find a perfect square trinomial from your homework. Let's see. I think I'm going to do problem 22 now. Problem 22 is a great problem. Great test kind of question. 36 m squared minus 24 mn plus 4n squared. Okay, first type of factoring I always do, GCF. I think the GCF is 4. I pull the 4 out. I can't lose him. Did you hear that, Joel? Don't lose that GCF. He's out in front of the quantity. So then I have a 9m squared minus a 6mn and a plus n squared. Now, I think this one is a perfect square trinomial. I'm not positive, but I'm going to check. 9m squared, the square root, 3m. Square root of n squared, n. Multiply and get 3n, double, get 6n. 6mn, excuse me, it matches. So I'm going to have my 4 out front. I'm going to have two quantities. All right, I'm going to have a 3m, an n, a 3m, and an n. If you're wondering about the signs, when there's a minus in the front and a plus in the back, the middle guy's lining up like the Wendy's double stack. There we go. Bam! Bam! This is too easy, guys. Too easy. All right. Now, by the way, if you wanted more problems, you could always open up your textbook. I haven't done a whole lot from the text recently. You could do problems from the different sections, or you could go to the chapter review and do problems. We're in chapter 9 right now. Okay, so I got to do one more. I got to do a factor by grouping. And I love factoring by grouping because it is so simple. It's just GCF, GCF, and then GCF one more time. All right, let's try problem 36. That's a good one. Y squared m plus y squared n minus 4m minus 4n. Remember to group. I have to have a GCF in each pair. So I want to put these first two together. Do I have a GCF? I sure do. I have a y squared and leaving a y squared times the quantity of m plus n, right? When I group the second two, I've got to grab that negative. That negative belongs to the 4, this negative right here. And then I put a plus between. Do I have a GCF? If you're saying 4, you're not thinking. Got to think a little bit deeper there, a little bit deeper. I'm not going to pull out a 4, I'm going to pull out a negative 4. So if I only pull out a 4, this is what I get. And then my two quantities, this one and this one, don't match. So I'm going to pull out a negative 4, which makes those change sign. And now I have y squared times the quantity of m plus n. Then I have minus 4 times the quantity of m plus n. And look at that, I repeated myself. The two underlying quantities now match. I can GCF them out. M plus n times the quantity of y squared minus 4. And I'm done! No way, Jose. Look at this this last quantity here. Look at this. What is it? Y squared minus 4. It's a difference of perfect squares. We're not done. We got to keep going. M plus n comes down for the ride. The y squared minus 4 will factor as y plus 2 times the quantity of y minus 2. And now I can say I am done. All right, I promise to keep the video short. I am under 10 minutes. The time police, naming Mr. Villarreal, won't call me on it. All right, Mr. Lawrence saying, have a great weekend. Get the rest of those problems done, and we'll do a little more practice on Monday. All right, Mr. Lawrence signing off.